Hello, I'm Carlos Rosa Suarez, and this is the CRS channel. We're going to continue with the physics problems in kinematics, and we'll finish up with problem 9 and explain something that was left out when problem 8 was being explained. Okay, so here we have the plots of position versus time. It shows an increase in the position as time increases, and shows a behavior corresponding to a curve. We have the plot of velocity versus time. This is the plot obtained from columns C and A. Which misleadingly seems to make one maybe infer that the acceleration would be constant, but this is not the case. This is the plot of acceleration. You can see how it varies. Varies quite a lot for the first values of time. This plot was obtained from the data in columns D and A. This is the plot of x position versus position divided by time versus time. This is the plot of dx dt versus time. This corresponds to the use of this formula here for velocity. And this is the plot of d2x dt2 which versus t, which corresponds to the use of this formula here. That is case of dx dt obtained from columns F and A, and for d2x dt2 from columns G and A. One thing to notice is that the graphs of dx dt and d2x dt2 the lines are smoother than in the case of B and A. That is, the values obtained from these two expressions present a smoother appearance than those obtained from these two expressions. Okay. Well, more accurate values could be obtained, of course, if the data set were to be better than what is presented here. So you could have more time values, and then the calculated values for x, for v and a, as well as for dx dt and d2x dt2, they could present a more accurate, they could be a more accurate representation of the velocity and acceleration of the particle. Okay, now let's go on to explain something from problem 8, which you can see by looking at the cells here. If you see these formulas, you see how they vary down the column. Although the form of the formula is the same, you can see that the cell references change as you go down the respective column. As you see the same thing. Here you have the use of a constant, which is typed in a specific number. Now, let's say you have a value from a cell that you want to repeatedly use in the formulas, but you don't want the reference, the cell reference to that value to change. So here we have an example of that. Here we have the use of this formula here. The velocity at a certain time is equal to the velocity of a previous time, it's considered as a reference, plus the acceleration for the time interval that includes both of these times, times the time difference between these two times. You can see this is the basic form used in the case of making the calculations on the spreadsheet. For example, here we have G23. This is G24. The value of G24 is equal to the value of the previous cell, that is G23, plus this term here times the time difference, which is F24 minus F23. Now, you can see that for G23, G24, G25, G26, we see that the cell references change respectively, so that for each cell reference, for example this one, G26 depends on the previous value, which is G25, plus this value indicated here, which doesn't change, times the time difference, the corresponding time difference. All the other cell references change except this one. So for that to be so, that is the reason why these dollar signs are included. If these dollar signs would not have been included, then the formula, this cell reference, would change, and for example, if it would have been D23 initially here, by the time one reached this cell reference, this would have changed to D24. and would have changed here to D25, here to D26, and so forth. Problem is that these cells have no values, so then I would get error messages if I would continue using this further down the column. So since D23 is this value, I use these dollar signs so that as I go down at least this part of the column by dragging down the fill handle, this cell reference doesn't change. So this value of the acceleration will be used for the calculations down to t equals 5. Remember that this is interval 1. So here we have the same expression, $d, $23. That means that this value is the one that is used for all these time values for this interval from 0 to 5 seconds. Okay, that's all for these two problems. We're going to continue on to problem 10 in the next video.